Hello, I'm back for the section C of this paper, that is Science Paper 2. It's right here, Paper 2, 5124 Science, Paper 2, 2022, which means it's the GCE paper. And this is our this is our section C video. So answer any two questions from this section in separate answer booklet provided, So this is very fair. Out of 3 questions, just answered 2. Okay, so our first question, C1. The following scheme shows some reactions of the dilute acid A. That is our acid, copper 2 sulfate plus water, substance C plus hydrogen, sodium sulfate plus water. So look at this before I even answer the questions. Sulfate, magnesium, substance B, copper 2 oxide. This is the base. That's a metal. That is substance B. Okay, already you can tell that this acid is sulfuric acid. Okay, because it results into formation of sulfate. So name and give the formula of dilute acid A. 2 substance B and C. Before I even look at the question, at the answers, let me just say you can tell just by looking, as I said earlier, acid A is sulfuric acid, which is H2SO4. Then substance C, this is our C. Magnesium reacts with sulfuric acid to give us magnesium sulfate and hydrogen gas. But let me just look at those answers. My answers are as below, that is A1, A, sulfuric acid. Therefore, name, they said name and give the formula. So we name and we give the formula. The name is sulfuric acid, formula is H2SO4. Okay, then substance B and C. So 2A2, that is B, is sodium hydroxide. And that's the formula. So how do you know it's sodium hydroxide? Look at the formula, look at the substances here. Acid A, substance B, then you have sodium sulfate, okay, sodium, and then water. Meaning this was the base because acids react with bases to produce a salt and water. So if this is water, and which base would react to sulfuric acid to give you the products as here? A salt and water, that is sodium hydroxide. So sodium hydroxide, the formula is this one. Then magnesium sulfate, MgSO4. So substance C, which is here, is magnesium sulfate. So you'll bring it out like that. B, allow me to just put my paper just on the side here so that it can be easy for me to shift. We have scored all the 6 marks here. So B, construct a balanced chemical equation for the reaction between substance B and dilute acid A. These questions are tricky if you have no idea of what you're doing, because once you mess up here, then everything will be wrong. Okay, so we already know that A is sulfuric and B is actually sodium hydroxide. Now they want us to construct a balanced chemical equation. So my construction was as here. H2SO4 plus Na plus NOA gives us Na2SO4 plus H2O. Then you balance it by putting these coefficients. That is my balance equation. Then question 2, B2, construct an ionic equation for the reaction in B1. Okay, construct an ionic equation for the reaction in B1. My equation is as this one. Okay, so I split everything that is in aqueous and leave all that is in liquid or solid. Okay, so my water is in liquid, I leave it in liquid. Everything else is in aqueous. So do a lot of practice for you to know how substances get to be labeled as aqueous, solid, or gas. So you can only ionize that which is in aqueous, not that which is in gas, liquid, or solid. So I ionize this to give me 2 of these. I put the 2 in front because they are 2 separate protons. Then our sulfate ion, then the 2 sodium ions, then hydroxide ions. This for 2, split these, and then you have water and liquid. Finally, I cancel out spectator ions, or ions that don't take part in the chemical reactions. In other words, ions that are present before and after the chemical reaction, like the sulfate ion. Sulfate is in form of, it's an aqueous solution. You mix with this solution here, which is having also ions. So before the reaction, this is already in aqueous, therefore in ionic form within water. And even these are ions which are in this form within water. So before the reaction, it is like this. After the chemical reaction, it remains just like this. so it doesn't take part in the chemical reactions as per se. So we cancel out the spectator ions or the ions that don't take part in the chemical reaction. So once I cancel out this, I cancel out that, and then also the sodium ions, I cancel them out. I cancel out the sodium ions. Then what I remain with are the protons and the hydroxide ions, which give me water. And so my ionic equation is this one here. Okay, so remember to know, read or check out how I have allocated my coefficients. Okay, the equation should be balanced. It should all start from this equation up here. Then if you want to write an ionic equation, net ionic equation, it should end in this way. State the type of reaction that occurs in B1. This is the neutralization reaction, because B1, which is this one here, B1 is where you're having a base reacting with an acid. This is a base which can also be classified as an alkali. Therefore, a soluble base can be referred to as an alkali, okay, or it can be referred to as being alkaline in nature. So base plus acid gives us a salt and water, and that is referred to as neutralization. And so there we go. We're done with our question C1. We go to question C2. Calcium hydroxide or slaked lime is an industrial alkali. Okay, is an industrial alkali. And the questions follow. Explain the meaning of the term alkali. A2, explain how calcium hydroxide is produced starting with limestone, which is calcium carbonate. Let me push in my answer there. I pushed the paper a little bit up there. So our C2A1, my answer or my writing was as below. CA1, a soluble base, okay, soluble base in water. So this solubility is with reference to water, being soluble in water. A substance that dissolves in water to produce hydroxide ions as the only anions. Okay, so an alkali is a soluble base, is a water soluble base, or you can even define it as a substance that dissolves in water to produce hydroxide ions as the only anions. And then the second question there is how calcium hydroxide is produced starting with limestone. Explain how calcium hydroxide is produced starting with limestone. Remember that limestone is actually calcium carbonate. So limestone or calcium carbonate is mined and roasted, in other words heated, okay, in a kiln or furnace, where it decomposes to calcium oxide and carbon dioxide as in the equation. So you have got this. When heated, it gives you calcium oxide plus CO2 in gaseous form. I was even debating whether I should use the term roast, but still more, you have to burn, you have to heat the calcium carbonate, and it decomposes in the presence of heat to produce this. The calcium oxide, which is this product here, is then dissolved in water to make calcium hydroxide, which is this. And this can be crystallized. Calcium hydroxide can be crystallized, but it can still dissolve back into water to give you an aqueous solution. So that's my explanation on this question, how calcium hydroxide is produced starting with limestone. Getting to the next question, I push my paper on the side. Give 2 large-scale uses of calcium hydroxide, 2 marks. Give 2 large-scale uses of calcium hydroxide. Okay, I got a little bit stuck here because I had to dig in my mind to think of the uses, but you can add on to this which I have here. But in my thinking, my answers were in the making of cement, okay, and then secondly in treatment of acidic soils, like on large farmlands which may have a lower pH, lower than 7, you may add some appropriate amount of calcium hydroxide to simply bring it to neutral for proper or conducive pH for crop growth. Our C2 question is a weak solution of calcium hydroxide is called lime water, okay, and it is used to treat carbon dioxide gas. Okay, let me read that again. A weak solution of calcium hydroxide is called lime water and is used to test, not treat, but test for carbon dioxide gas. C1, construct a chemical equation for the reaction, include state symbols. So the chemical reaction of lime water reacting with carbon dioxide. C2, give the chemical name of the salt produced during the reaction, and the reaction in 2, which is calcium carbonate. And then C3, describe what is observed during the reaction. Describe what is observed during the reaction. Let me just get to the answers. So my answer there is calcium hydroxide aqueous, because it's a weak solution of calcium hydroxide in aqueous, plus carbon dioxide gives us calcium carbonate, a solid, okay, which is observed in form of a white precipitate, or which makes the lime water milky, or some people even say cloudy, okay, milky or cloudy. And water, okay. So number 2, calcium carbonate is the name of the salt produced in this chemical reaction. This is a salt, a carbonate. It's a salt because it results from, it can result from carbonic acid, okay. You know the definition of a salt. It's a salt that can result from carbonic acid. Then lastly, a white PPT is formed. That's the observation which is made in the chemical reaction. So I go back to the question a little bit. Construct the equation. That's the equation we had right there, where you have calcium hydroxide plus carbon dioxide giving us calcium carbonate, a solid, and water. Giving the name of the salt, that is calcium carbonate. Then finally, describe what is observed during the reaction. A white PPT is formed, or precipitate. It's okay to write PPT in the exam. Okay, it's an official, it's an accepted initial for precipitate. So that white precipitate is actually the formation of calcium carbonate. It's actually calcium carbonate. I jump on to question 3, C3. Propane is one of the many important hydrocarbons obtained from crude oil. Crude oil is sometimes referred to as heavy oil. In some books, we refer to it as petroleum, a combination of many fractions. Okay, so propane is a component. Oh no, it's one of the many important hydrocarbons obtained from crude oil, not a component. Like propane, it is made up of molecules which contain 3 carbon atoms. The first question, which is 3A, draw a structural formula of propane. Draw a structural formula of propane. The structural formula of propane is this one here. Oh, sorry, they say draw a propene. So be careful. There's an E here. Okay, there's an E here and there's an A here. This one is unsaturated, but this one is saturated because of the ANEN. Pene means that it's an alkene. So this is our alkene. You can put the double bond here or here, doesn't matter, but put the double bond somewhere. The naming won't change. So that's our structural formula. Next question is, how does propene differ from propane in terms of bonds? My answer, or my pick, was propene has a double carbon to carbon bond, while in propane all carbon to carbon bonds are single. So when I say propene has a, meaning one, this is one double carbon to carbon. So this is not, this just means carbon to carbon, C to C. Okay, so that's the main difference there. In other words, propene is unsaturated with a single double bond, whilst propane is saturated with no double bonds. But propene has a single double bond. The next question is, give the molecular formula of propane and propene respectively. These are free marks, people. Free marks. So formula of propane and propene. My answer there is C3A1 to 3, alkenes. Have I skipped something there? To which group of hydrocarbons does propene belong to? Yes, to which group of hydrocarbons? It's an alkene, or alkenes, unsaturated hydrocarbons. Then now finally give the molecular formula of propane and propene respectively. The molecular formulas are here. Propane, that is C3H8. Propene, C3H6. Remember to master the general formulas of the 5 basic homologous series: alcohols, esters, alkanes, alkenes, and carboxylic acids. Okay, so B, let's check out what B is all about. C3B. Explain why propene reacts immediately with bromine water, whereas propane does not. Explain why propene reacts immediately with bromine water, whereas propane does not. My answer there is the double bond in propane is a reactive site or functional group, which makes it reactive, while propane has no unique active site. So the double bond in propane, like here, gives it an unusual a site where there is a high negative charge Okay, this is a double bond. Therefore, these are 4 electrons that are crowded in the same space. So it creates this negativity on one end, and this other end becomes relatively positive. So this one becomes your reactive side. So this molecule is highly reactive because of that uneven distribution of electrons. Whilst in propane, which doesn't have any unique distribution of uneven distribution of electrons. Let me just write it down. Propane is something like that. That is our propane. 3 carbons and 8 hydrogens. Look, there's no double bond like between carbon to carbon or anywhere, so it's kind of uniform. So it's much more stable compared to one which is negative, which has a negative field because of the clustering of electrons in this double bond. So my answer there in B1 is the double bond in propene is a reactive site, okay, which makes it more reactive, while propane has no unique active site, therefore making it more inert. Okay, more inert. So the double bond breaks to leave only one bond, and it reacts with bromine water and results into decoloration of the bromine water from orange to colorless. B2, describe what will be observed during the reaction. Describe what will be observed during the reaction. The observation would be the bromine water is decolorized from orange, or the bromine water would be decolorized from orange, meaning to be decolorized meaning to have this colorless appearance like water from orange, therefore from orange to colorless. C, that is C3C. Propene is obtained by breaking down longer chains of hydrocarbons. What is this process called? Okay, what is this process called? The process of breaking down longer chains of hydrocarbons to shorter chains. In this case, our example is propene, shorter unsaturated chains. The answer is cracking. If you want to be more specific, you can say thermocracking. Thermocracking doesn't involve a catalyst. Instead, it involves a little bit of higher pressure, or it involves much more pressure and temperature to simply break down longer or larger hydrocarbon molecules to shorter ones. And thermocracking results into production of more of unsaturated hydrocarbons and also aromatic hydrocarbons, therefore ringed or circular or ringed hydrocarbons, whilst catalytic cracking results into production of shorter chains that are saturated. Catalytic cracking results into production of more of shorter chains that are saturated, but thermocracking results into production of shorter unsaturated hydrocarbons. C3D, propene is a monomer for making an important plastic. State the name of the polymer it forms. State the name of the polymer it forms. The polymer formed by propene is polypropene, okay, and this polymer is an additional synthetic polymer. Additional means the monomers are unsaturated, so they only get to join by the breakage of one between the two bonds at their unsaturated points to come up with this polymer. Okay, only one product is formed, the polymer. And then artificial, meaning that it is just made. It doesn't, this polymer doesn't occur naturally in living or biological systems. So it's an artificial additional polymer. This marks the end of this paper finally. I hope it was helpful. Remember to pause the video and rewind it where you don't understand, and leave your comments or something like that. Otherwise, for now, allow me to say goodbye. Okay, allow me to say goodbye, and I'll see you in the next video, either in biology or physics. Bye bye for now.